So what is an Atwood's machine?
It goes whoop.
It goes whoop. Good. And we've done it in intro 1. Right. And we did it only using Newtonian wave. So now we're also going to add on Lagrangian and Hamiltonian. Okay. Woohoo! So let's do the simple one first. Or do you guys want to do the complicated one with the mass of the pulley? Simple? Okay. So let's say this is my Atwood's machine. And the length of my string is L. If this is X, over the pulley is pi r, and then this one will be L minus X minus pi r. Do we know why there's a pi r adding up? Right, so we have to account for the string that's over the curve.
X is representing the entire string.
So now, what's the first one we're going to do? I'm going to call for masses M1 and M2, and I'm going to call M1 plus M2 as big M, and I'm going to call M1 minus M2 as the change in M. That's just terminology I'm going to use. And I am going to assume M1 is bigger than M2 because I want an accelerated system. So what will this pulley do? It will go which way? Towards M1, right? M1 will come down.
Which one's M1?
That one's M1.
One left.
And this one is M2. Okay, now we are going to start Newton's method. That was our first one, right?
Correct. We've done this. Let's do it again.
Let's do it again. You guys can do it. So for Newton's way, we have to pick our coordinates. What do you guys want to do? X or Y or X, or can we just use X? Let's just use X. Okay, and X is pointing upwards. So then Y will be pointing this way, right? Right-handed coordinate system. X, Y, and Z. And Z will be pointing towards me. So this is X and this is Y. Then we are going to use a bent coordinate system. That means X is going to go down. So in Newton's way, how many equations are we going to use? One for mass 1 and one for mass 2. Does Y matter? No. So it'll be sigma Fx equals, so there will be a tensional force, T1, T2, and a force that points from the center down, M1G and M2G. So the sum of the forces is going to be, so sigma F will be F1 plus F2 plus F3 and so on. The pulley does not have mass. Okay, what will these equations look like? T minus M1G and sigma Fx will be T2 plus M1G. Ooh, thank you. Okay, where is the acceleration? M1 is bigger than M2. What will be sigma Fx for 1? Yeah. Right, it's going, is the acceleration going this way?
Yeah.
And is this one going to be going upwards? So then it'll be still so what will we get? Minus M1A equals T1 minus M1G. And minus M2A equals minus T2 plus M2G. Are both tensions equal? So can I get rid of the subscripts? Can I add both of these terms? So can I add both equations together?
Yes.
Will that make my t go away? So what will I be left with? M1 plus M2 A minus equals minus M1 plus M2 G. So will my acceleration be M1 minus M2 divided by M1 plus M2 G? There's a minus sign here. May I rewrite this acceleration as delta M over big M G? You have seen this expression before in intro 1. There was a whole lab where you did this. With the Atmos machine, right? You took one mass and you exchanged the mass over all the time. Did you not? And you found out how faster and faster it was going. Okay, so this is the expression we are looking for. A equals delta M over big M G. Let's call this equation A.
A for Atwood.
That's a good one. Yeah, we can do that.